So many times it comes up in a titration about what is the pH of the reaction or of the solution when you reach the equivalence point. And if you think about a strong acid such as HCl and think about a strong base, in that reaction, again, think about even in terms of what do you have left? You're going to make water. The H is going to go with the OH to make water, and the Na is going to go with the Cl. In terms of solubility, though, in terms of net ionic equation, this is a strong acid, so it breaks apart. Sodium hydroxide breaks apart, and sodium chloride breaks apart. So really, all that you're making in a strong acid, strong base titration is you're making water. And so anytime you have a strong acid and a strong base, at the equivalence point, the only thing you're going to have is water. So that at that point, the pH of that solution will be exactly 7. So when you're looking at a titration curve, here's your equivalence point. The pH will be right at 7. Okay, now that's only when you have a strong acid with a strong base. Okay, most reactions, most titration reactions, you don't have that. Okay, for example, let's change HCl to HF. Okay, well, HF is not one of your strong acids, it's a weak acid. So in terms of net ionic equation, obviously this isn't going to be NaCl, it's going to be NaF. This is a weak acid, so it does not break apart, it doesn't dissociate. The sodium is going to dissociate and make hydroxide, and then over here as well. So there's our net ionic equation. So again, at the equivalence point, what's left? All of this has reacted, all of this has reacted. All we have left is this. So at the equivalence point, all of the reactants are gone. All you have left are products. Now, the issue is this thing right here. Okay, is that F minus is the conjugate base of a weak acid. And remember, that's all you have floating around in there. And what happens is, and again, I mentioned this in a previous video real quickly, but what happens is that fluoride ion is going to go through what's called a hydrolysis reaction. Okay, and a hydrolysis reaction is one where it reacts with the water. And F minus is going to react with the water that's there, again, to create an equilibrium system where that's the conjugate base, so it's going to accept a hydrogen from the water to reform a very, very little of that HF. More importantly, though, what's left when water loses the hydrogen is you get hydroxide ion. Okay, and again, right now we are at the equivalence point. Okay, we don't have extra hydroxide, but that fluoride ion is going to hydrolysize with the water that's there, and it's going to reform, again, some of those HF particles, and more importantly, some hydroxide ions. And hydroxide ions make the pH go up. So again, at the equivalence point, the pH is going to be greater than 7. Okay, and that's the important part. You don't even know exactly what the pH is going to be, but anytime you have a weak acid, strong base titration, the pH at the equivalence point is going to be greater than 7 because that conjugate base, because this was a weak acid, this is a stronger conjugate base, which means it can react with the water to form some hydroxide ions. Okay, with a weak base, the same thing happens. If you have a weak base titration where you're reacting it with a strong acid, you're going to get NH4 plus, and then that Cl minus is actually going to cancel out on both sides. Okay, and you end up getting this. So at the equivalence point, what do you have? You have water and, again, the ammonium ion, NH4 plus. Okay, and again, this is a base, so it's going to form a conjugate acid. So NH4 plus, again, is going to hydrolysize with water. And again, this is the acid. And so in this case, water has to act like a base. And so it's going to accept that hydrogen. So what's it going to create? NH3, and more importantly, H3O plus. Oh, and H3O plus makes the pH go down. So again, instead of the pH being equal to 7, the pH is going to be less than 7 again for both of these at the equivalence point. Okay, so a weak acid titration, back up here to this one, a weak acid titration with a strong base at the equivalence point has a pH greater than 7 because that conjugate base is going to create some hydroxide ions. Okay, a weak base with a strong acid titration is going to have a pH greater than 7 at the equivalence point because, again, the conjugate acid of that weak base can react with the water to create hydronium ions. Okay, so here we can see this kind of in a table. So if it's a strong acid, strong base, at the equivalence point, you're right at 7. There is no hydrolysis that occurs. Okay, with a weak acid and a strong base, so that's the first example we saw, the pH is going to be greater than 7. It's going to be a basic solution at the equivalence point. Because again, what happens, the conjugate base of that weak acid reacts with water to create more of the acid, more importantly, the hydroxide ion. Okay? And then the opposite, a weak base with a strong acid, again, is going to be less than 7 because, again, you've got that conjugate acid, here it is, the NH4 plus reacting with the water to create some ammonia and, more importantly, some hydrogen ions or hydronium ions, and that makes the pH less than 7. Okay, and honestly, a weak acid, weak base, you're not going to see that on the AP exam, so don't even worry about that. Okay, so here it is, just again, one more time. In simpler terms, when a titration of a weak acid and a strong base is at the equivalence point in the following reaction, the only species present are the conjugate base and water. And again, all of those reactants have been used up. There are no reactants left at all. All of these are completely gone. Okay, so since the original acid is a weak acid, its conjugate base is a strong conjugate base, and it's going to react with the water in a hydrolysis reaction to reform a small amount of that acid particle and the hydroxide ion. And again, it's the hydroxide ion that causes that pH to go up a little bit above 7. Okay, and again, same thing here with a strong acid, weak base titration, that you've got that conjugate acid left over. It's going to react with the water to form some ammonia and some more NH3 plus. The hydronium ion, that's what causes pHs to go down. So the pH is less than 7 at the equivalence point. So remember, what determines the pH at the equivalence point is what the products of the titration are and how those products will react with water.